In this video, we're going to take a look at a word problem using systems of equations. And so in step 1, I always suggest that we skip to the end of the question and determine what it's asking for. These are your variables. And so you definitely want to be writing these down and telling yourself what they are. So as you're rating them, keep these in mind. And so I'm going to jump right to the end here. Blah, 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 blah. If the company spent blah, blah, blah producing these coffee, how many of each were made? Okay, so I've got 2 coffee makers apparently, or at least 2. So now I go back and it says a manufacturer produces 2 types of coffee makers, 6 and 12. Okay, so I'm going to let X represent the number of 6 cup. Y is going to represent the number of 12 cup. Okay, again, it's not that bad. You're just differentiating between the two because you want to be able to, when you get done, interpret what you just did. Otherwise, you did it for naught, and it's not really all that much fun, is it? So for step 2, read the problem. Write down all of the numbers and what they represent, and then write down any relationships between variables. Okay, so now we have a manufacturer produces 2 types of coffee makers, a 6 cup and a 12 cup. The 6 cup coffee maker takes $10 and 2 hours to produce. The 12 cup coffee maker takes $15 and 4 hours to produce. If the company spent $1,240 and 306 hours producing these coffee makers, how many of each were made? Okay, so we've got some. What I'm going to do is I'm going to make a couple things here. I'm going to make kind of a table because I think that's going to be easiest to organize my data. And so 6 cup cost hours. And then let me scroll down here just a little bit. I'll put on my 12 cup. Okay, so now my 6 cup costs $10. Go back and make sure. $10 and 2 hours to produce. My 12 cup took $15 and 4 hours. Okay. Total, I spent $1,240 and 306 hours. Okay, so now I've got my I have my variables defined. I have the relationships in between the 6 cup and the 12 cup. Now it says if it's feasible, draw a picture. If you want to draw a picture of them manufacturing this, you can go ahead. I don't see that it's all that feasible. It's not really going to give me an insight into what's happening. What would give me an insight as to what's happening is to remember that when I'm done, I need the same numbers, which means if I'm coming up with cost, if I'm saying I'm going to take $10 and multiply that by the number of 6 cups, that's my total cost of 6 cups. Total cost of 6 cup produced. And so I might write something like that down just to remind myself, hey, that's the total cost. It's the amount that you spend per item times the number of items. Well, I've kind of done that for you in step 4. It says write down an equation or 2 or more. In this case, we're only going to need 2 in the end, that describe the problem and or the picture using the values of step 2. I gave you 3 little equations here. And when you're dealing with systems of equations, and especially in the rates, whether they be interest rates, whether they be rates of mixture, whether they be costs, that sort of thing, very often you're going to find out that these problems tend to follow what this is saying. And so very typically you'll have 2 of these 3. The first one is how much plus how much is a total. This is usually done with counting. So for instance, if you have coins and it says you have a total of, you're saving dimes and nickels and you have a total of 27 coins. Well, that means that if you take the number of dimes and the number of nickels and add them together, you get 27. How much plus how much is a total? In our case, we have two rates here. We have a rate of cost for each item and then a total cost. We then have a rate of number of hours produced and then a total number of hours used. So we're actually going to use the second one twice. Here's how this works. The rate of cost, and I'm going to do cost first, is $10 per 6 ounce or 6 cup plus $15 per 12 cup must equal our total amount spent. A rate, $10 times how much? X. Remember that we defined X to be the number of 6 cups and Y to be the number of 12 cups. So our total cost, you add up the cost of the 6 and the cost of the 12 together, you get the total. You do the same idea with the hours. It takes 2 hours to produce the 6 cups, and it takes 4 hours to produce the Y cups, or the 12 cups. The total time you're going to take producing these things is 306 hours. And now you have 2 equations, 2 variables. At this point, how you solve this is completely up to you. However, what I'm going to do is I'm probably going to use some form of elimination, but first I'm going to rewrite these. And 2x plus 4y is equal to 306. The reason I'm going to rewrite these is I'm going to try to keep these in the same color to show you how I do this on real paper. I am going to take and divide, since 10, 15, and 1240 are all divisible by 5, I'm going to take 1/5 of equation 1. That's going to give me 2x plus 3y is equal to, and now I have to take 1200 divided by 5, or 1240 divided by 5. So, hand it in the calculator, because I'm a little lazy today, and we get 248. By the way, use a calculator. At this point, when you have large numbers like that, just go ahead and use a calculator. The odds are, with large numbers, you'll make a few mistakes. So I would have used a calculator for that no matter what. All right. So now we've got number 2. Each one of them are even, so I'm going to divide by 2. The effect is multiplying by 1/2. I always try to multiply and add whenever I'm dealing with these. That's going to give me x. It's going to give me plus 2y. And half of 300 is 150. Half of 6 is 3, so it's 153. Okay, so now I've got my system here. I'm going to go ahead and solve this using elimination. And so I'm going to tell you what I'm going to do. I'm going to take equation 1, and I'm going to add in -2 times equation 2. It just so happens that I'm basically going to undo what I did for equation 2. However, I recommend that you at least try to reduce it. You may have to go back and use it, and you'll see that with more experience. But if you reduce it, it's going to give you smaller numbers, less chance of error. All right, so now I'm telling you what I'm doing. I'm going to just talk my way through this now. 2x plus a -2 times x, which is -2x. That gives me 0x. 2 minus 2 is 0. 3 plus -4, because remember I'm multiplying it by -2. 3 plus -4 is -1y. And then I have 248 plus a negative. And so I take 248. I'm going to bring up my calculator so you can see what I'm doing here. and I'm just doing what I'm told. I'm doing what I've told myself I'm going to do. I'm going to take 248, and I'm going to add negative 2 times 153. And that gives me negative 58. And now when I do this, I get negative y equals negative 58. Remember that 0 times x is 0. That's all 0. If I divide by negative 1, that's going to give me y is equal to 58. At this point, if you want, you can go ahead and use substitution. And I think that's going to be the way to go with this. And so I'm going to take my y value, and because the numbers are smaller, I'm going to shove that right in there. So I've got x plus 2 times 58 equals 153. That gives me x plus 116 equals 153. If I subtract 116 from both sides, 4 gives me 20, and 33, that's 37. X equals 37. Okay, and so let's go back, and before we get too heavy into this, remind ourselves of what the variables represent. X was the number of 6-cup coffee makers produced. Y was the number of 12-cup coffee makers produced. So 6-cup, 37 produced. 12-cup, 58 produced. And there we are. Now, do they make sense? You got to test that. Does it make sense? Well, they're not negative. That's a good thing. And they're not fractions. If we came up with a negative, that would mean that they made less than 0. That doesn't make any sense. If we came up with a fraction, that means that they only partially made one. And that doesn't make any sense, because they need to produce them in whole units. So at least the numbers themselves make sense. What you can do is you can take this back, take these values, put them back into your equations to see if they work. And then if they work, what that does is it tells you that your answer is consistent with your equation. It does not tell you your answer is correct, because you could have screwed up the equation. And so be very, very cautious on being too confident. But at the same time, when you get done, if your answer makes logical sense as far as the real world is concerned, it's probably right. So just go ahead and you can go back and check to make sure that you did the math right. But ultimately, you're just going to have to, have the confidence that you did what you were supposed to do and is correct.